So the area under the normal curve. This image that we have here is an image that I'm not asking you to cement into your minds, but it is a really, 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 really important image or illustration of the normal curve that I want you all to keep, right? Keep in the sense of record this into your notes, and include the percentages, include these numbers down here that say -1, -2, -3 sigma, or +1, +2, +3 sigma. So include all those pieces, and I'm going to make sure to explain to you right now what it is that those pieces represent. So remember that I mentioned that the curve of our distribution represents the capturing all data, right? All of our data exists underneath that curve. And so what that means is if we were to apply, this idea of a percentage to it, 100% of cases or outcomes in a normal distribution fall under the normal curve. The normal curve accounts for every single instance of something happening. All right. So this means that all possible outcomes are accounted for. Recall from measures of variability that standard deviations, this sigma symbol, measure the average deviations from the mean. Under a normal curve, standard deviations function the exact same. And so this means that standard deviations measure an average distance from the mean of the normal curve. And so if I were to include, and really on this image, I should have included to start with, there should be this symbol right at the middle. So this is a symbol that we've been introduced to before. This is mu. This is represented on either the previous slide or 2 slides ago, representing the mean falling right in the middle. Okay. Now, I still haven't explained the percentages and the, +1, -1, so on and so forth. You ready for that? I don't know why I'm asking, because we're about to do it. All right, let me find out what happened to my mouse. Get rid of that. All right, here we go. Understanding the normal curve. We have this sigma that we've seen before, standard deviation. As we apply this concept to this normal curve, we want to begin to think about standard deviations in kind of a sense of units, right? So where we see +1, -1, +2, -2, +3, -3, standard deviation, I want you to think of them as units. And the reason that I say that is because those are distances, and we measure distances using units, right? And more often than not, if we're thinking about distance in a way that we commonly conceptualize it, talking about miles, how far something is away in terms of miles. So apply that same kind of thinking to this idea of standard deviation units in the context of the normal curve. So while not marked in this image, the line in the middle represents the location of the mean. You would read this +1, you would read that as one standard deviation above the mean. Okay, we talk about these standard deviation units in reference to their position relative to the mean. So this +1 represents one standard deviation above the mean, which then means that this one to the left of the mean is one standard deviation below the mean. You would apply that same kind of language to describe 2 standard deviations above the mean, 3 standard deviations above the mean, or 2 standard deviations below the mean, or 3 standard deviations below the mean. Now, I know they have these positive and negative symbols. Those will be relevant later. But in terms of how I want you to practice using the language of statistics in the context of the normal curve, like I said, I want you to think of them as +1 reads as one standard deviation above the mean, -1 reads as one standard deviation below the mean. Now let's discuss these percentages here. So I'm going to start with this 68.26%. Percentages that you see on the normal curve relate to an area under the normal curve between standard deviation units. And so what this means in the context of this 68.26% And notice that these arrows extend to the line drawn at 1 standard deviation below the mean and 1 standard deviation above the mean. Now I'm going to erase the red markings that I've drawn up until now, and I'm going to use some different colors to help emphasize some important points about these percentages. I'm going to draw around the 68.26%, and then I'm going to kind of attempt to color in the area that is represented as 68.26%. Okay, so this area that I've shaded represents the area between 1 standard deviation below the mean and 1 standard deviation above the mean. And the percentage that that area represents is 68.26% of a population. Now, we have not yet applied this information to a specific example. As soon as I'm done explaining these percentages, I'm going to do just that. But hold on to the idea for now that when we describe an area under the normal curve, we describe it as a percentage of a population. All right, so 68.26% of a population exists between 1 standard deviation below the mean and 1 standard deviation above the mean. Now I'm going to erase the red markings that I've included here, and I'm going to choose another color. I'm going to choose green. And using this green, I'm going to highlight this 95.44%. Notice that the arrows associated with 95.44 extend out to this line drawn at 2 standard deviations above the mean and 2 standard deviations below the mean. So what this means is I'm going to very carefully color in or shade in the area that this 95.44% represents. Doing this very carefully. I can be a bit of a perfectionist at times. I apologize for that. Y'all probably don't care. You just want to understand the information, and I respect that. Okay. Now, in this area that I've shaded, we would describe this area as 95.44% of a population is found within 2 standard deviations below and 2 standard deviations above the mean. Now, notice that I've also shaded in the areas that were previously marked red for this 68.26%. And that's because in my extending the area that I'm discussing, I have to incorporate that smaller area in the middle, right? This 68.26% exists within the area that is now covered when describing the population that exists between 2 standard deviations below and 2 standard deviations above the mean. All right. So technically, I could have left this area red to still be reflective of talking about 68.26%, but I didn't want to confuse anybody. So just make sure you understand that when we're now discussing 95.44% of the population, we are also incorporating that smaller area in between, right? The 68.26. And let's go ahead and I'm going to erase the green. I'm now going to use purple. I'm going to highlight this 99.74%. Notice that the arrows that extend outward from 99.74, you don't see the line, the full line drawn at 3 standard deviations below and above the mean, but that's where those arrows are intended to stop. Right here at 3 below, 3 above. I'm gonna try and let go of my perfectionism and just color this in as much as I can, because I just want to emphasize that now that we're talking about 99.74, that is representative of the area between 3 standard deviations below and above the mean. Okay, so that's everybody. Well, not everybody, right? Because remember, 100% of cases are under the normal curve. we at least know that 99.74% of them exist between 3 standard deviations below and 3 standard deviations above the mean, which means that the difference between 100% and this 99.74%, which roughly calculates to what, 0.26% of the population, exists, beyond the 3 standard deviations below and above the mean. But we'll get into that more in just a moment. But suffice to say that this 99.74 is intended to be representative of everybody within, 3 standard deviations below, 3 standard deviations above the mean.